everyone, welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about physical characterization of nanogel. Now, our expert Professor Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Daikon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nano-bio-interface science, soft matter science, polymer physics and biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without a skip.
Now, here you see the particle size and the nanogel without any drug here. And the model drug in this case is actually the BSA. So, with the BSA here, for this experiment that I'm displaying just now, you can see the particle size here hardly has changed in the light scattering measurement, DLS measurement. It has remained same. Size close to about 100 to 200 something nanometer, 200, 250 nanometer or so. This is in the phosphate buffer saline solution. You see the hardly is visible there. After the fluorescent level is added to it, it's showing up very nicely because of the fluorescence, and this is the equivalent TAM picture of the nanogel. Okay, so this is the nanogel in different medium before and after UV radiation. So the size you see is hardly changed. This is the blank, there is no FITC loading here. So the hydrodynamic radius is about 150, 160 here, either in the microemulsion or with the PBS, in presence of UV, in the absence of UV, the variations are all shown here. So after ultraviolet radiation, you can see there is change in the size here. You see nanogels confined in emulsion after UV radiation. You can see the size is reduced to this. Whereas nanogels redispersed in PBS at 7.4, again, because of the swelling, it gets to a much higher size of 220 nanometer. This is for without FITC sample. This is with FITC sample in there. The variations are marginally there, but this information is required for further application in the biology. Here the stability is shown as function of time, okay, of both the blank nanogel and FITC labeled nanogels here. Blank nanogels, you see these open circles here, is stable over a period of 160 hours. FITC loaded also equally stable. There's not much deviation. Close to about 200 nanometer here, and the blank one is about 210, 220 nanometer here. Polydispersity, the red line that you see here, is also more or less constant. So the size and the morphology actually do not change with time. That's what it shows. Now these cells, the nanogel samples, now are tested against cells, Morin fibroblast NIH3T3 cell viability.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And you see in day one, as a dose-dependent situation, you see the cell viability almost 100%, has not changed much in day one. And day three also, the results are more or less acceptable. The same region, it's not changed much. Okay, so after multiple repetitions of these things, so we see that the cell viability of this particular fibroblast cell is highly acceptable, the experimental condition. Now you see how the transdermal drug delivery works in this case. So it's basically a skin permeability test. In the top panel, you see A, B, and C. This is the drug delivery or the BSA delivery to the system, FITC, BSA conjugate only. No nanogel was used here. So you see, it's only sitting on the surface. It's not penetrating into it, to the deeper layers. So the microscope images clearly show that FITC BSA did not permeate deeper into the layer, and basically you can see large accumulation of this on the surface in the stratum corneum in the pictures A, B, and C. Whereas when the delivery is through nanogel, same material loaded in the nanogel and is now delivered through the nanogel, you see that has gone deeper into the stratum corneum, D, E, and F pictures. So this confocal images, fluorescence images clearly tell the story that nanogels are effective drug delivery mechanisms. It creates a pathway for percolation of this model drug deeper into the transdermal system. Now, this is a typical, pathway description of how the skin penetration works for this. So, in the top side, on the upper plane, you see the structure of the skin or different components of that. And the bottom layer, the second panel, you see how the permeation deeper into the transdermal system happens. So the typical stratum corneum's thickness is about 15 to 20 microns. So the drug molecule has to pass through this, percolate through this, and permeate into deeper. So there are three possible routes of it getting into it. One is a transcellular route, or intercellular route, or follicular route. So in these model experiments, all these possibilities were exhausted, and it was one definitive conclusion that was given from this experiment that it is possible to deliver model drugs deeper into the SC by choosing a delivery through the nanogel mechanism, which was not possible when we did not use the nanogel. Okay, now the skin penetration study that we see here, and we have the data tells us that the penetration is much, much deeper in the case of a GN-based delivery. This opens up a new possibility of transdermal delivery of drugs using nanogels, where nanogels can be a good platform for carrier of these drugs.
I hope you like this video. Further, I would like to give you an important information that Nanoscience and Technology Consortium organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel on Star and also hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.